Hello and welcome to the second session of our Elec 342 labs in electromechanical energy devices. In this lab session, we'll give you a quick introduction about the single-phase AC transformer that we have here. The experiments you'll do in this lab will include measuring the parameters of the single-phase transformer and testing the transformer with different loading conditions and seeing the phenomenon called the inrush current that is common in AC transformers. The first step that you need to take is measuring the parameters of your AC transformer. Any electromagnetic device in electrical engineering has a mathematical model, and to be able to do calculations and analysis on these devices, we need a mathematical model which depends directly on the electrical parameters of these devices. First, we need to calculate the resistance of the transformer. One way is to use a multimeter. This is the setting for measuring resistance. It has two settings. One says 2 watts and 4 watts. Since we are not going to inject power into the transformer, we just press 2 watts. Then you will need to connect the probes to your multimeter. The probes that you need to connect are to these terminals. If I connect the probes into one side of the transformer, the measurement that I'm going to get is displayed on the multimeter. As many of you are familiar with how multimeters work, you can measure the resistance in this way. This case, one important thing to note here is that we are measuring the resistance of the transformer winding plus the resistance of these wires. So we need a way to be able to isolate and come up with the exact resistance that is present in the transformer. So the way to do that is to repeat the measurement, but this time double the length of our probes. This will allow us to have two different equations for two different resistance measurements, but here we're going to have two unknowns. So with this, we're constructing a two unknown, two equation system, and then we can calculate the exact resistance in this transformer by using this technique. So we do this for the other side of the transformer as well. We come up with a number here, and then we repeat this measurement by using only single wires for probes. So we can do the exact same procedure for the other side. Now, there's another way to measure the resistance of a transformer, which is using a DC power supply, applying a very small voltage and measuring the current. The second way to measure the resistance of a transformer windings is to apply a small amount of voltage to one of its windings and measure the current that is going through the winding. So I'm going to use this DC power supply here to have the voltage ready. I will connect the power supply terminals to one of my transformer terminals. And before I turn on the DC power supply, I will make sure that the voltage knob is 0. I don't want to burn the transformer by accident if there is a high voltage on the DC power supply when I power this on. So I will set the voltage to 0, that is counterclockwise all the way, and then turn on the DC power supply. you see that the voltage is 0 right now, and the current is nearly 0. By using this knob, I can increase the voltage that is being applied to the transformer. You see that I have nearly 0.4 volts applied to the transformer, but this small amount of voltage is giving me nearly 2 amps. That means that the resistance of the transformer windings are relatively low, and you need to be careful when you're doing this test. You're gonna have to measure the resistance at 3 different currents. I would say 1 amp, 2 amp, and 3 amps. And you measure a resistance for each of the currents, and then you calculate the average of that resistance, and you can come up with the resistance that you are going to use as your final value. You will have to repeat the same procedure for the other side of the transformer, and that way you can measure the resistance for the other side of the transformer as well. It is important to note that the measurement that we did with the multimeter, we repeated the measurement in one case with 1 wire as a probe and then 2 wires as a probe. You should remember that you have to repeat the same procedure with the DC power supply, meaning that in one case you need to apply the voltage and measure the current using 1 long wire here, and then you need to double the length and do the same again. And this way you are basically recreating a 2 unknown 2 equation system, and that way you can come up with the exact resistance on the transformer windings. To measure the open circuit voltage of our transformer and determining the operating point, we need to apply an AC voltage to one side of the transformer and measure the currents that is going through that side and measure the voltage on the other side of the transformer. This way we can calculate the turn ratio of the transformer, and we can determine which point is the operating point of our AC transformer. To do this, we can wire up, we will use our 3-phase AC power supply. We are going to use only 1 phase. This is the way, this connection you see here is the way we can get a higher voltage with the Y delta transformer here. We are going to need like higher voltages here, and then you will connect the current meter. The current meter is connected in series. You connect your power supply to the positive terminal of the current meter, and then you connect the negative terminal to the terminals on your transformer. Then you will need to connect your voltmeters as well to your transformer. Make sure that you connect the positive terminal of the voltmeter to the negative terminal of your current meter on the same side. Then you will need to connect your second voltmeter to the other side of the transformer, making sure that the polarities of your voltmeters match on both sides. So positive on this side, negative on that side. To measure voltage and currents, you will need to use the GUI that is designed for this specific measurement for the transformer. As you can see the voltages and currents that are currently being measured on the transformer. Those are 0 because right now there are no voltages being connected. The power supply is off. When you open this and everything is off, make sure you remove the offset on the current meter by pressing 0 amps. This way, if there is any electrostatic on your current meter, This will remove that offset caused by electrostatics so that your measurements would be accurate. Now, to start the measurements, I will turn on the power supply. First, I will make sure that the power supply is off. That is, the knob is all the way back in counterclockwise direction, and making sure that the voltage knob is all the way to 0. I will then turn on the power supply. As you can see on your measurements, there's a small amount of voltage and current because the voltage is set to 0. I will start to increase the voltage, and you can see at the same time on your measurement window the effect it has on the current going into the transformer winding. You can see that I'm applying a sinusoidal voltage, but I'm getting a distorted current. That is due to magnetic saturation, and you will know about that in detail in the class. Right now you see that I have connected my second voltmeter, but to see the voltage measured by second voltmeter, I need to activate my second channel here on this on this bullet here. Okay. This V2. When you click that, you can see that your second voltmeter is displayed by color red here, and you do the same for I2. You see that I2 is 0 because we haven't connected anything to our secondary side. So the next test is the short circuit test, and we need to do that to be able to determine, to calculate the transformer parameters. To do the short circuit test, first we need to turn the primary voltage all the way to 0 because we are going to short circuit the secondary side. We turn the primary voltage back to 0, turn the power supply off, and then we will use 2 wires to short circuit the secondary side through a current meter because we want to read the current that is going through the secondary side when it's shorted. And we can leave the voltmeter connected on the secondary side, but it's going to show 0 voltage because it's short circuited. To continue with the short circuit test, double check that your voltage is 0 and turn the power supply on, and slowly increase the voltage. The limit, your limit would be the current on the primary side, which should not exceed 5 amps, which should not exceed 3 amps. You see that the voltage is very small, but the current that I'm measuring is very high compared to the voltage that I'm applying. This is the short circuit test, and you need to save this data, and you are going to use this in your parameter calculation for your transformer. So another test that we are going to do on our transformer is load test. In this test, we will put an electric load on the secondary side. In the lab, you will do this as a completely resistive load, a resistor, an RL load that you see here, which is a resistor connected in parallel with an inductor, and then you will do it on a third case, which you use an RC load, which you connect a capacitor in parallel to your resistor. Here in this demonstration, we are using an RL load connected to the secondary side. You see here that the secondary side is connected to the load through a current meter, and so that we can measure the secondary current. And you see that the voltmeter is connected as before to the secondary side. Now, again, make sure that the voltage is 0 before you turn on the AC power supply. It's very important you remember that. I've already done that. Now, I will turn on the AC power supply. There's no voltage here because I've set the voltage to 0 on the AC power supply. And when I gradually increase the voltage to the nominal value, which we determined in the open circuit test, which was 8.6 volts for this transformer, you see that I have currents. I have current through the secondary winding, I have current through the primary winding, and I have the measurements for the secondary side, voltage and current here, and the primary side, voltage and current here. You're going to use these measurements to calculate the parameters of your transformer. You also need to repeat this experiment with the purely resistive load and an RC load. You see here that when I change the resistance, I'm changing the load, I'm changing the current that is going through the secondary side, and you are going to test this for different loads and fill out your tables in your lab manuals.
When we energize an RL circuit from an AC source, and depending on where on the voltage wave of the source we close the switch, that initial current might reach very high values, much higher than the final steady-state current. A transformer is an RL circuit. When we energize that transformer, we will observe that phenomenon, and that maximum peak value is known as the inrush current of the power transformer. In this experiment, I invite you to set up your oscilloscope so you can see as many cycles as possible and can observe the inrush current phenomenon. Please let the TA do the switching for you.
The final test that we are going to do here is testing something that happens in AC transformer, which is inrush currents. In AC transformers, when you connect a voltage to your primary side, when the transformer is not energized, there will be an inrush current, a current with very high peak going through the transformer windings, and it depends on where we are in which point in time we're connecting the voltage to the transformer. The circuit would be the same as the open circuit test, and we already connected the AC power source to our primary side, and the secondary side is also connected, and we have the current meter and voltmeter on the primary side as well. To do this test, you need to increase the voltage on the primary side to 120% or 130% of your nominal voltage. Keep a close eye on your measurements on the monitor, so you don't exceed that amount of voltage. As you can see, we have nearly 120% of our nominal voltage on the primary side. Now, to be able to capture the transient on the primary side when we are going to connect the voltage, I will increase the capturing window to nearly 2 seconds so that I will have enough time to pause my measurements when the transient happens. To disconnect your power supply from your transformer, do not turn off the power supply. So you simply pull out one of the wires, and you see that the measurements will go to 0. And to reconnect your power supply, you just pull in connect the wire to your AC power source, and when I do that, you see the transients with enough time for you to pause the figure. So this is the way you are connecting your AC power supply to the transformer. You are going to do the inrush current test for two cases. One case when there is a high amount of inrush current when you connect the voltage, and another case when there is nearly no inrush current. And then you will compare the voltages at the moment of energizing the transformer, and you'll see the effect of the voltage at the moment of energizing on the inrush current.